As you saw in the last volume, basic navigation involves using visual checkpoints and time, speed, and distance calculations. In this volume, you will be introduced to other forms of navigation that use aircraft radios and ground transmitting stations. The first form of radio navigation we'll look at is the VHF omnidirectional range, which is commonly referred to as VOR navigation. A VOR station continuously sends out signals that are received by a radio in your airplane. The station is shown on an aeronautical chart by a compass rose surrounding its location. The compass rose is a graphic depiction of the signals transmitted from the VOR. These signals, called radials, extend out from the station and are numbered clockwise from magnetic north. Although the number of radials is infinite, only 360 are used. Their directions are indicated by numbers on the outside of the compass rose. Your position in relation to the VOR is usually expressed in terms of the radial on which you're located. Here, for example, the airplane is on the 090-degree radial. To receive the signals transmitted by a VOR station, you need certain airborne equipment. The antenna picks up the signal and relays it to the VOR receiver. Here it is interpreted and then sent to the VOR indicator, where the signal is displayed as navigation information. This visual display has three components. They are the course selector, the course deviation indicator, and the to from indicator. The course selector, also known as the omni-bearing selector, or OBS, allows you to set the desired course. The numbers and tick marks on the VOR indicator ring correspond with the numbers on the compass rose of a sectional chart. The course deviation indicator, known as the CDI, helps you determine your position relative to the course. If the needle is centered, your airplane is located on a radial. If the VOR indicator is set properly, the to from indicator tells you whether your selected course will take you to or from the VOR. When you see an off or nav indication, one of two situations has occurred. Either the signal is too weak to use for navigation, or you have just passed over the station. Now that you have a basic understanding of the VOR components, let's look at how to put them to practical use. The first step is to select and tune in an appropriate facility. Station information is represented on an aeronautical chart by a box located near the compass rose. This box includes the name of the VOR, the three-letter identifier, the Morse code identification, and the station frequency. To use it for navigation, your first step is to enter the frequency into the airplane's receiver. Turn the frequency selector knob until 117.5 appears in the display window. On this receiver, the frequency is set in the standby window, then transferred to the use window. Always verify that you have tuned in the correct frequency and that the station is in service by listening to the Morse code or voice identifier. With the station tuned and identified, it is easy to determine your position. Simply turn the OBS knob until you get a from indication. Remember, radials go out from the station. Continue turning the knob until the CDI centers. The number under the index is the radial on which you're located. Keep in mind that this display tells you where you are in relation to the station and not to the heading of the airplane. Here, for example, the airplane is located on the 070-degree radial from the station. The airplane could be pointing in any direction, and the VOR indicator would still read the same. However, the heading in relation to the VOR indicator does play an important role when you want to fly toward or away from the station on a specific radial. To fly away from the station on the 070-degree radial, all you have to do is turn the airplane until the heading indicator and radial under the index are in agreement. With the from indication and the needle centered, you'll fly away from the station on the selected radial. If you want to fly toward the station, rotate the OBS until you have a 2 indication. When the needle centers, note the number under the index. This is the magnetic heading to the station. Now turn the airplane until the heading indicator and radial under the index are in agreement. With the needle centered and a 2 indication, you'll fly toward the VOR. It's important to remember that when the VOR and heading indicators are in agreement, a 2 indication will take you toward the station, while a from indication will take you away from the station. This assumes that there is no wind to drift you off course. The CDI is the component on the VOR indicator that provides wind correction information. If you drift off course, the CDI will point in the direction of your desired course. A good way to visualize your position is to picture the airplane at the bottom of the VOR indicator. If the needle is to the left of the airplane, your course is to the left, and you need to make a heading correction to the left to get back on course. If the CDI moves right of center, your desired course is to the right, and you need to make a heading correction to the right. The dots along the bottom of the VOR indicator show you how far you are off course. Each dot represents 2 degrees. In this case, you're 8 degrees left of course. You need to change your heading to the right to get back on course. The amount of correction you need will depend on the strength and direction of the wind, as well as your distance from the station. In this case, a 20-degree correction angle is used to regain the course. As you near the desired course, the CDI will begin to center. When you're back on course, you'll need to turn to a heading that compensates for the wind. A good technique is to use half the original correction angle you used to regain the course. In this example, you would use a 10-degree wind correction angle. If the correction angle is too great, the airplane will drift upwind. If you are close to the desired course, simply turn to parallel the radial and let the wind drift you back. A correction angle may be required if you are farther from the course. Once you're back on the radial, apply half the original wind correction angle, which in this case is 5 degrees. There are occasions when you want to track to or from a station on a different radial than the one you're following. This requires you to leave one radial and intercept another. To help explain the intercept procedure, let's assume you're tracking outbound on the 070-degree radial and you want to be on the 090-degree radial. You should first visualize where you are and where you want to go. It's a good idea to turn to parallel the new course before you make your intercept correction. This helps to ensure your intercept is in the correct direction. Now, rotate the OBS to enter the desired course in the course selector. To intercept the 090-degree radial, you'll need to turn right. Continue to fly the heading until the CDI centers. When you have intercepted the new radial, turn to a heading that will allow you to remain on course with the needle centered. The intercept angle you choose depends on a number of factors. If you're flying toward the VOR at a point far from the station, a fairly large intercept angle might be required. When you're close to the station, a shallow angle can be used. If you use a small intercept angle when flying outbound, it may take a long time to reach the new radial. Since the radials diverge away from the station, a larger intercept angle may be necessary. Although VOR navigation is quite simple, you should be aware of a few unique factors, such as reverse sensing. This happens when you select and fly on a radial that is 180 degrees from your heading. When this occurs, the information provided by the VOR is opposite the normal indications. For example, to track to a station on the 070-degree radial, you need to set 250 in the course selector, then fly a heading of 250 degrees. If you mistakenly set 070 in your course selector, then fly inbound on a heading of 250, you will experience reverse sensing. If you drift to the left of course, the CDI gives a false indication that your desired course is to the left. Based on the instrument indication, a correction in the direction of the needle causes you to drift farther off course. You can avoid the problem of reverse sensing by keeping the course selector in general agreement with your heading indicator. Another unique characteristic that you may experience is a CDI fluctuation. Certain propeller RPM settings can cause the CDI to fluctuate as much as 6 degrees. You can eliminate the problem by varying the RPM slightly. Let's take a look now at how to use the VOR to determine your exact position. You've just seen how to locate where you are in relation to the station. While this procedure allows you to determine your direction from the station, it does not tell you how far you are from the station. Assuming you are on the 300-degree radial from this VOR, let's use a second VOR to pinpoint your position. First, tune and identify a second station. Next, turn the omni-bearing selector until you get a from indication and the needle centers. The course under the index, 240 degrees, is the radial on which you are located. Plot the radials from both VORs on your sectional chart. The point where the two lines intersect is your exact position. Becoming familiar with radio navigation will enhance your basic navigation skills. The information provided by VOR serves not only as a backup to pilotage and dead reckoning, but also provides accuracy in determining course, distance, and position. In the next section, you will be introduced to the Automatic Direction Finder, commonly known as ADF. When using this navigation aid, you will be able to apply some of the techniques you learned in this section.